In number 47, a family has a plot in the community garden. The family is going to plant vegetables, flowers, or both. The diagram shows the area used by one vegetable plant and the area of the entire plot. The area F in square feet of the plot left for flowers is given by the equation F equals 180 minus 1.5 V, where V is the number of vegetable plants in the family plants. Okay. What do we got here? Find the intercepts of the graph of the function. Well, the graph of the function, you've got F equals 180 minus 1.5 V. So we can think about, usually we have Y and X, but nothing really changes here. If you want to find the F-intercept, you'd make V0. So you'd say F-intercept, what's 180 minus 1.5 times 0? Well, that's just 0, so the F-intercept is going to be 180. If you want the V-intercept, you'd have to solve this equation. If you want the V-intercept, you plug 0 in for F. So you'd have to solve, when does 0 equal 180 minus 1.5 V? You'd have to subtract 180 on both sides to get negative 180 equals negative 1.5 V. Divide both sides by negative 1.5. You're going to find that V equals, I believe it's 120. So our V-intercept is going to be 120. Part B asks us to graph the function, identify the domain and range. Well, since we have the intercepts, graphing this is going to be relatively easy. I'll focus on the first quadrant since we can only have positive values. Instead of the x-axis, we're going to call that our v-axis. Instead of the y-axis, I'll think of that as my f-axis. So I've got flowers and vegetables. Okay, my f-intercept is 180. I obviously can't go by ones. I think I'll go by, maybe I can squeeze 20. There's 20, 40, there's 60, 80, 100, 20, 140, 160, 180. Again, this would be the number of flowers, or I guess the square feet of flowers. And our V-intercept, the vegetable intercept, is 120. Again, I can't go by ones. Maybe I'll go by tens. There's 10, there's 20, 40, 30, 40, 50, 60, 70, there's 80, 90, 100, 110, there's 120. And this is going to be our vegetable plot and how many square feet we have of that. So if the F-intercept is 180, I'm going to make a dot at the F-intercept at 180. V-intercept is 120, make a dot there. The last step is to just connect the dots. But you have to think, oops, that wasn't a very good line between them. Let's try that again. There we go. You have to think a little bit in this situation. You can't have negative flowers or vegetables. So I'm going to peel this back and make it stop right there and stop right there. So really you have a line segment. They ask for the domain. The domain is what you can plug in for x. Well, the x values go anywhere from 0 all the way up to 120. So we'd say 0 less than or equal to v less than or equal to 120. Your range is talking about your flowers here. So the range goes from 0 in a low point to a high point of 180. So 0 less than or equal to the flower square footage, less than or equal to 180. Part C, the family decides to plant 80 vegetable plants. How many square feet are left over for plant flowers? Well, 80 on the vegetables. Let's find 80 on the vegetables. That's right here. If we work our way up to see where it hits on the graph, it looks like they've got about 60 square feet left to plant for flowers.